In this lab, we have 4 sets of resistors. Each of them is of different resistance. We have one that is 1 kilo ohms of resistance. We have another that is 100 ohms of resistance. And lastly, we have one that is 220 ohms of resistance. We have 4 sets of them, and we are going to set them up in different configurations and test the resistance of all of them. To do this, we have a breadboard here. We also have a multimeter with these probes and also these alligator clips that we are going to attach onto them so we can measure them at convenience. Each of these resistors have lines on them, and these lines determine the resistance of them. That is how you can calculate the resistance, and you can do this by going online and seeing which each color band means, or you could turn on your multimeter to measure the resistance. To measure resistance of a resistor, you're going to attach one of the clips to the resistor, and then on the other leg you're going to attach the other clip. Once you do that, we can see that this resistor is 100 ohms of resistance, and we see that there's a 0.5. So these resistors have a golden band at the end, and the golden band means 5% error. So we can also measure these other resistors. So we're going to measure this one. This one is approximately 220 ohms of resistance. And then we have this last one, which is approximately 1 kilo ohm of resistance. For our first configuration, we are going to set these up in series. So we will plug them into the breadboard. It doesn't matter which of these holes that the resistors plug into, they just have to be like this. The first one doesn't matter at all. Now the next one, and also these are not in order, so we don't need to worry about that. But the next one that we're going to plug in, one of the legs has to be in the same row as our other resistor. That way we follow the lines of continuity on our breadboard. And the lines of continuity is the continuous current or voltage that's being driven through each of these lines. So for the middle ones, each row is the line of continuity, and then for these longer rails on the side, the power rails, the line of continuity goes all the way down for the negative, and then all the way down for the positive. For this breadboard, the red is the positive, and the blue is the negative. So this is the current configuration that we have. So before I put this next resistor in, it is come to my attention that the actual resistor is in different probes. And this doesn't matter. It can be in the same line like this, but it also doesn't matter because the lines of continuity, as we mentioned earlier, the current or resistor is fine being in any of these lines. They just have to connect like this. That means that if we wanted to connect these in series, they don't have to necessarily be right next to each other. They could be connected like this, and the resistance is still connected together in series, as long as they are located on the same line of continuity as they are right here. Now we are going to plug in this third one, so we gotta make sure that it is on the same line as our previous one, and then just plug it into any of these. Now we're going to measure this in series. To measure in series, we are going to take one of our legs and put this measure on it, and then we're going to take the other probe from our multimeter and put it on the farmost leg. If we do this, we're going to get the measured value as approximately 1.13 or 1.12, it keeps fluctuating, ohms. So this is the resistance of our resistors. Now if we wanted to calculate this using the theoretical values, we would use the resistors in series calculation. The formula for resistors in series is this. It's R1, so our first resistor, plus our second resistor, plus our third resistor. And this is all in ohms. We know one of our resistors is 1 times 10 cubed, our next resistor is 220 ohms, and our last resistor is 100 ohms. This 1 times 10 cubed is the 1 kilo ohm resistor. Now if we add all these together, we're going to get 1,320 ohms, or 1.320 kilo ohms of resistance. And this is approximately what we got for our measured value. Now we are going to look at part B for this lab. And that means we are going to have 3 resistors in parallel with each other. So for resistors to be in parallel with each other, we are just going to have them inserted like this. Now the next one that we insert, remember the first one doesn't exactly matter where we insert it. However, the next one that we insert has to be in the same column for each of these. So the leg of this resistor has to be in the same column of the leg for this left resistor, and the same thing for the right. So when I plug this in, it has to be in the same column for both of our legs. It's going to go in just like this, and we can see that they are both in the same column. Now we're going to do the same exact thing for the third resistor. We're plugging it in just like this. Now that we have our 3 resistors in parallel set up, we are going to measure them with our multimeter. So we're going to take our probes, and how we measure this one is we attach one of the probes to the top or bottom of this, and then we're going to take the other one and touch it to the bottom with the opposite side. And if we do this, we can see that we get a measurement of approximately 64.5 or 64.6, 64.7. It's an approximate number of ohms of resistance. So this is again our measured value from our ohm meter. For the calculations, we're going to use the formula for resistors in parallel. And the formula for resistors in parallel is that we're going to have 1 divided by our first resistor, plus 1 divided by our second resistor, plus 1 divided by our third resistor. This is all surrounded in parentheses, raised to the negative first power. This is the formula. In red is our resistor values that we are plugging in here, and after we carefully plug that into a calculator, we're going to get approximately 64.33 ohms of resistance, and that's the resistance that we measured, approximately. For part C of this lab, we are going to have these three resistors that we are looking at. This one is our 1 kilo ohm resistor, and these are either 100 ohms or 220 ohms. Now, whichever one we put in series, because how we're doing this for part C is that we have one in series, and then this branches off to 2 in parallel, which come back together. So the one out front matters. The 2 in series don't necessarily matter. So it's important how you do this. If you put a lower resistor in front in series, there is going to be lower total resistance. If you put a higher resistor out front, you'll get a higher total resistance, and we're going to demonstrate that. So we're going to take our 1 kilo ohm resistor, and we are going to plug it in like this. Doesn't matter, just make sure it's in the same column. We're going to take either a 100 or a 220 ohm resistor, and we're going to plug it in. This has to be in the same column, and then whatever column this one is plugged into, it doesn't matter. Now we're going to take our last one. This left leg has to be in the same column as these other two, and this right leg has to be in the same column as this right one. So we are going to plug this value in here, and we can see that our resistors are all lined up looking like this. This looks good, and we can now measure it. So we are going to take our two probes. We can measure this one of two ways. First, we're going to choose one of these, and we're going to put it on the left resistor that's in series. We're going to take our other one, and we're going to put it either on the top or the bottom. It doesn't matter since they're in parallel. So we're taking this leg and putting it on this resistor. If we do this, we can see that our result is approximately 1.62 kilo ohms. Now this is if we have the smallest resistor out in front. Plugging in our 220 ohm resistor, we have 311 ohms of resistance. And I made a mistake. The kilo ohm resistor that was out front is actually the biggest resistor, because 1 kilo is 1,000. So we basically had 1,000 ohms of resistance right here, and then we had 220 and then 100 up here. It was 1.060 kilo ohms, meaning it was a really big number, because we're going to take 1.060 and multiply it by 10 cubed. So that was the bigger one. So this still holds true. I just got my exact values mixed up. The one that we measured first was the bigger one, and this is the middle tiered one. If we take this 100 ohm resistor and put it out front, we would get a smaller value, because it is smaller than both the kilo ohm resistor and the 220 ohm resistor. So if we do this, attaching it to this leg, and then I'm going to attach it to this leg, and then we can see that out of all three of those measurements, we're going to get the smallest value at 280 ohms of resistance. And that is how we would solve for part C. This is a measured value in the ohm meter. To calculate the theoretical value, we have to go into OneNote and solve for this. We are going to have these two be resistors in parallel, so we're going to use the parallel formula for it, and then we're going to add it to this resistor that is in series. For the calculated theoretical values, this is the formula we will be using. So we are first going to combine these two resistors since they are in parallel. Once we combine them, we're basically just going to get a resistor in the middle here. Remember, because these two are combined, they're collapsed now. We can see that this middle resistor is in series with our R1. That's why we are adding this and this together. All we need to do is plug in our respective values. Now, the values may be different depending on how the resistors are arranged, but we would just plug whatever is in our top in our R2, whatever is in our bottom, which is R3, would go in here, and lastly, our R1 is going to go right here. Once we do that, we can plug all of that into a calculator and then get our answer. If our theoretical answer is close to our measured value, that means we did the math and set up our resistors correctly. In part D of the lab, we are going to have our resistors in a parallel and series configuration. So we're going to have some current flow through this, and then we are going to have it split in parallel. We're going to have two resistors like this, and then a resistor right here. So we'll have two resistors on the top in series with each other, and we're going to have one resistor on the bottom that's in parallel with the two resistors on the top. So all of these are going to be in parallel once these two series are combined. We're going to set this up. We're going to have our 220 ohm resistor go on the bottom. We're going to have our 1 kilo ohm resistor go on the top first, and then our 100 ohm resistor on the top after it in series. I'm going to start off plugging in the 220 ohm resistor. We're plugging this in wherever, and now we're going to plug in our 1 kilo ohm resistor. This resistor has to be in the same column for both the left and the right legs, and it's going to be in parallel just like that. So these resistors are both in the same column. Next, we're going to plug in our last resistor, and it's in series with our top resistor. So this is what our resistor configuration will look like. Now to measure this, we can do it one of two ways. First, we are going to connect the bottom to our right resistor. Once we have this, we are going to connect our other one to either the top or the bottom. The order doesn't really matter. You're going to get the same result for either of them. But once we connect this, we're going to get 281.1 ohms of resistance. That is the measurement for this resistor setup. Now, if we want to change these around, there's multiple different ways that we can rearrange this. We just got 280 approximately ohms of resistance, but let's say if we were to switch these two resistors. So we're going to switch the 1 kilo ohm resistor with our 100 ohm resistor, and then we'll measure this. In doing that, we see we get 1.060 kilo ohms of resistance. So that is the difference in measurement, and it will change as we rearrange the resistors. For part D, this is the diagram of the circuit that we just created of the resistors that we just set up on the breadboard. Now, depending on what values we have for each R1, R2, and R3, we're going to get different measurements. However, we should make sure that the R2 that we are plugging in here is the same resistor in the R2 position on the breadboard, and the same goes for our R3 and R1. Otherwise, we may get different values. But since these first two resistors up here are in series, we can add them together. That's what we do right here, and we set it equal to an R23. That is what we made up. We're storing R2 and R3 into our R23 so that we can plug it into the parallel formula, because these two series resistors are in parallel with this R1. Once we do that, we are going to get our answer. And if, again, our answer is similar to what we measured, that means we did the math correctly and we also measured correctly. To write the lab report, we need the cover page. After the cover page, we're going to have the title, objective, and then lab preparations and challenge. We're then going to have a paragraph summarizing these preparations and challenges. And then after this, we are going to have a diagram of our actual breadboard. And this diagram is going to be showing the lines of continuity. And that's basically the direction of connection through all of these. So we have continuity through this whole negative side, continuity through this whole positive side. So we have continuity through this whole negative rail, continuity through this whole positive rail, and then we are going to have continuity through all of these columns and only these columns for the middle of our breadboard. Then we're going to have our results. We have individual resistor values, resistor configuration values, both the calculated and measured value, and lastly we have a conclusion, and that is how you would go about doing this lab.